Hello guys, welcome to this set of videos, and what we're going to do in this set of videos is they will follow along with the notes that come out of your guys' textbook from Chapter 7, Section 5, and we're going to continue looking at exponential and logarithmic functions here in Chapter 7 and here in Section 5 of Chapter 7 as well. Specifically though, we're going to talk a little bit more about solving logarithmic equations. We're going to look at an interesting kind of problem we run into based on something we learned in Section 4 of this chapter and how we're going to deal with that issue when we come across it. But before we get into that, let's get a couple of objectives or learning targets to kind of help us focus as we go through these videos and this set of notes. So here's the things you guys are going to want to be able to do, the things that I'll test you on if you're taking this class with me. These are the things I'll test you on at the end of this chapter and section. So you'll need to be able to simplify and evaluate expressions using properties of logarithms. And that first objective is going to be the one where we're finding a way or sort of discovering a new way to deal with an issue stemming from problems we've done in previous sections. I'll show you exactly how that's going to work here in a second. Then what we'll do is we'll move on later pages of the notes here, solving logarithmic equations using the properties of logarithms. So we'll get you the properties of logarithms, and then we'll take a look at solving some of those problems. Before we jump into those objectives and learning targets, though, I just, again, real quick, because it's really important, and I want to make sure that you guys get this. And it's this right here. Remember, the logarithmic function simply means that y is the exponent that the base must be raised to in order for it to be equal to x. This means that logarithms are exponents, all right? I've said this a few times. I'm going to continue to say it. It's very, very important. The logarithm is the exponent. Remember the way that this works. If I have x, now let me do it right here, x is equal to b to the y power. What I've got here is an exponential function. I have x equals b, the base is b, and it's raised to the y power. This y right here, that exponent, is the logarithm of x. And when I ask you to find a logarithm, what I'm asking you to do is figure out what power, what does this exponent need to be, so that when I raise b to that exponent, I get x. Now we use that neat little method that I showed you to help us figure out what the logarithm is, right? How do I write this as a logarithm? Well, we showed you guys the Snail Method, which is when you start at the base and you work your way around the equal sign. And so it's going to be the Snail Method. That's going to help us go back and forth between the exponential and the logarithmic function. So I start with the base, so I'll need a log base b. So my base of the logarithm is going to be b. I work my way around the equal sign, so I'll be taking the log base b of x. And that's going to be equal to, keep working my way around the equal sign to y. And remember, the reason we call it the Snail Method is if you just keep that little snail going in there, you get yourself this cute little snail show, and you can draw yourself a snail on there if you want to, give him eyes and ears. And remember, I like to call him Gary, and he likes to meow. So the Snail Method, and again, you can go either direction. I could do the Snail Method over here, right? The log base b of x is equal to y. Well, what if you knew y and you had to solve for x? X is what you're trying to find. Well, the way this would work is you would just do the Snail Method starting at the base, and you'd work your way around the equal sign. Again, you could complete it and draw your snail in there, but it would be base b, raised to the y power is equal to x. So the Snail Method lets us go back and forth between an exponential and a logarithm, or a logarithm and an exponential. And again, a logarithm is nothing more than an exponent. You're trying to figure out when you take, right, when I take a logarithm base b of x, finds me y, and y is the exponent, right? The exponent. If I raise b to that exponent, then I'll get x, all right? So it's really, really important. I'll continue to say this probably at the beginning of every section of notes that we do. Very, very important that you understand what a logarithm is. A lot of Algebra 2 students kind of freak out when it comes to logarithms, and I think it's mainly because they really don't understand what it is that they're doing. So as long as you guys recognize that the logarithm is nothing more, it's just an exponent, and anytime I ask you to find a log, I'm asking you to find what is that exponent? What exponent do I need there, right? What do I have to raise the base to? This base needs to be raised to a power. You're finding that power. Okay, now, the problem or the issue that we're going to deal with today. Let me refresh your memory real quick on something we did in a previous section. We got this equality property of logarithms. And here's what that equality property says. It says that if the log base b of x is equal to the log base b of y, if and only if x is equal to y. And so what we did is we used this property of equality for logarithms to say that if I have a log base b and it's equal to a log base b and those bases are the same, then all I have to do is set the arguments equal to each other, right? And then I can solve for a variable, and we use this to solve equations. But please notice what's happening here. I have a log base b on this side and a log base b on this side, but that's it. It's a log base b with an argument equal to another log base b with an argument. Just for example, real quick, let me show you what these look like. We solved one that probably looked very similar to this. Log base 2 of 2x is equal to log base 2 of, I don't know, let's say x minus 3. Right, and so what we did in the previous section is we said, oh, property, the equality property of logarithms will work here. I have a log base 2 and a log base 2, so all I have to do is just set 2x equal to x minus 3, and I can solve for x. No problem. But here's what we're going to do in this set of notes. What if I gave you one that looked like this? Log base 2 of, I don't know, let's say x minus log base 2 of, let's say, 4x is equal to a log base 2 of x minus 3. Okay, hopefully you can kind of right away recognize why this is different than what we did in the previous section. What I've got here is I don't have a log base equal to a log base. What I've got is I've got a log base minus a log base equal to a log base. And this property only applies if it's log base of an argument equals a log base of an argument. So this minus sign in here, this subtraction sign, is going to cause me some issues. Same is true if it were an addition sign. I could just as easily made that plus. It's still going to give me problems because then this property doesn't apply in this case. So what we're going to do with the first objective, we'll look at it on the next page of the notes, is we're going to learn some properties of logarithms that will allow us to simplify this. We can simplify it. And once we simplify it, then the property we learned in the previous section will work for us. So this is the issue. This is what we're going to face in this set of notes. I'll show you how we fix that problem, and then we'll use the property to help us solve these logarithmic equations. Head on over to the next page of the notes. We'll get started. I'll meet you there.